Hello guys, welcome to Code with BK. So in this video we will see how to solve the problem of converting a decimal to binary. So decimal is basically base 10 value which is stored as integers or long in our programming languages, and binary are base 2 values, zeros and ones, right? We usually store binary values as strings, right, for convenience. So first we'll see how to approach this problem, how to solve this, and then we'll look at the codes. So if you just want the codes, the links to the code in the description of this video. And to each code for a programming language, I have written a text explanation as well. So if you are somebody who wants to read and understand, you can visit the link and check the explanation as well.
Please do not forget to subscribe to this channel and click on the bell icon to receive all the latest updates.
So decimal values are basically base 10 values that we use in our day-to-day lives, right? For example, 1, 2, 3, 4, 5, right? Base 10 means it has 10 separate digits to represent a quantity, a value. So digits for base 10 are 0, 1, 2 till 9, okay? And for binary it is base 2 and its digits are 0 and 1, right? So we have to convert a quantity which is represented by these 10 digits into a quantity which is represented by zeros and ones, right? So there is a standard method of converting decimal to binary. We look at the method first and then we see how we convert that method into our code. So let's first see an example on how to convert a decimal to binary. For example, I have 23. Okay, I have to convert this 23 into base 10 to some value into base 2, right? So this is how you represent base, all right? So what do is we divide 23 by the base to which it is to be converted, as long as this does not go to 0. So we keep dividing it by 2 as long as it does not go 0. So when we divide it by 2, we get 11 with a remainder 1. We divide this 11 by 2 again, we get 5 with remainder 1. We divide this by 2 again, we get 2 as remainder 1. We get 1 remainder 0, we get 0 remainder 1. First step is keep dividing this value by 2 as long as it does not go to 0, and then append the remainders in reverse order. So 1, 0, 1, 1 and 1. So 23 base 10 is basically 1, 0, 1, 1, 1 in base 2, right? Let's look at another example. 16, right? Okay, you divide it by 2, you get 8, remainder 0, you get 4, remainder 0, you get 2, remainder 0, you get 1, remainder 0, you get 0, remainder 1. Appending them in reverse order, you have 1, 0, 0. So 1 and 4, 0 into base 2 is basically 16 base 10. Alright. So this is the step we code in our solution. So we start with our pseudocode. So we'll store a binary value into a string. So I'll say binary value is an empty string, right? N is the integer we want to convert it into binary, right? We know our stopping condition that we stop when n goes to 0. Until then, we keep dividing n by 2. So while n is not equal to 0. Okay. So before we divide n by 2, we have to store the remainder when n is divided by 2. For example, when we are dividing 23 by 2, you get 11 as the result, 1 as the remainder. How do we find the remainder? We use the percent symbol. So A%B returns the remainder when A is divided by B. So I'll say our remainder is n% 2. Then you have to divide n by 2. So we do n by 2 and store it back into n. So these two steps are basically getting the remainder and dividing by 2. We have to append the remainders in reverse order, right? So the first remainder comes at last. So we say BV concatenate R to the left of BV, right? So after this loop ends, this variable will store the binary value for this integer. Let's take this example of 23. Okay, BV is blank, n is 23, right? We have R. Okay, so we start as n is not equal to 0, n is not equal to 0 is true. We go inside, R is n%2, n%2 gives me 1, and n is equals to n by 2, this becomes 11, and BV is R plus BV, so 1 comes to the left hand side, so this becomes 1. Okay, we check n is not equal to 0, true. We get R is n%2, n%2 is again 1. We get n is equals to n by 2, we have 5 here. BV is 1 plus BV. So we have 1 and 1. Okay, this new 1 comes to the left end. Okay, n is not equal to 0, n is not equal to 0 is true. We have r is n percent 2, which is 1. We get n is equal to n by 2, which is 2. BV is 1 plus BV, so we have 1 to the left, so it becomes 1, 1, 1. We check n is not equal to 0, 2 is not equal to 0 is true. We come inside, r is n percent 2. 2 percent 2 will give you 0. We divide n by 2, it gives you 1. We get BV is r plus BV. 0 comes to the right end, so left end we have 0, 1, 1, 1. Then we go back to while loop condition again. N is not equal to 0, 1 is not equal to 0 is true. N percent 2 will give you 1. N is equal to n by 2. 1 by 2 will give you 0 because this is integer division, right? Then BV is r plus BV. This comes to the left end, so it is 1, 0, 1, 1, 1. Okay. This while loop condition is checked. 0 is not equal to 0 is false. So this is your binary value. Two things to note down here. First, this case will not work if n is 0. So suppose if your n is 0, right? This condition will be false. For n is 0, I want BV to be 0. For n is equal to 0, this loop will never be executed. So BV will stay a blank string instead of 0. So we basically take an if-else case. So we do if n is equal to 0, we simply set BV equal to 0, else we do this while loop part. Okay. Another thing is we lose the value of n after this loop. N goes to 0, right? So if you want to store the value of n, so basically you say temp stores the value of n, and after this loop you can set n to temp. So this is how you convert decimal to binary, and let's look at the code stuff.
So this is the implementation in a Java code, and I've written a function that implements the solution that we just discussed. So this method takes an integer n and returns a string which is basically the binary form of n. We take the case of n is equal to 0 separately, where we set binary value to a string with a single 0. Otherwise, if n is not 0, we follow the while loop solution. Okay, and finally we return the binary value. So in my main, I am testing the conversion of 10 to 56, 1, 2, 3, 4, 0 to its corresponding binary values. So let me run this Java C, okay, and Java. So you see all cases are correct. So I hope this video was helpful. So please do like this video, subscribe to my channel. Please post it in the comments if there is anything not clear to you in this video, if there is a concept you want me to discuss, or if there is a question you want me to solve. Thank you.